Hello students, in today's class we will discuss how temperature affect the value of equilibrium constant Kc or Kp. As we know, there are two type of reactions. First are exothermic reactions, and second one are endothermic reactions. Endothermic reactions. Exothermic reactions are those reactions in which when reactant gets converted into product, heat is released. That's why delta H or enthalpy change of these reactions are always negative. And second are endothermic reactions. Endothermic reactions are those reactions in which heat is absorbed from surrounding. So when reactant gets converted into product, heat is absorbed. Hence delta H is equal to positive value. So especially in exothermic reactions, when we increase the temperature, if we increase the temperature, then the value of equilibrium constant is decrease. And in endothermic reactions, when we increase the temperature, the value of equilibrium constant Kc is increased, and the reactions for which delta H is 0 means the reactions which neither absorb nor release the energy, these type of reaction temperature does not affect the value of Kc of these type of reaction. So we have to understand what is the reason behind that. Okay, let's understand. We have an equation, that is Arrhenius equation. That is K means rate constant is equal to A E minus EA upon RT. From this Arrhenius equation we can derive a relation like that: log K2 upon K1 is equal to delta H upon 2.303 R 1 by that is delta H 1 by T1 minus 1 by T2. So we are taking three cases. In case number 1, if delta H is 0. So first of all we have to understand what are T1 and T2. T1 and T2 are two temperatures, and at T1 temperature the rate constant for a particular reaction is K1, and for T2 temperature the rate constant is K2, and let T2 is greater than T1. So delta H, case number 1, when delta H is 0. So if this value is 0, then what happen? That whole will be equal to 0. So in that case we can say log K2 by K1 is equal to 0. And if log K2 and K1 is equal to 0, so we can understand the value of log K2 minus log K1 is equal to 0. So in that case we can say K2 minus K1 is equal to 0. It means K1 is equal to K2. Means if delta H is 0 for any reaction, then we can say the K1 is equal to K2. Case number 2. If delta H is negative, then we can understand the whole value of log K2 by K1 will be negative. So that is for exothermic reactions. Exothermic reactions. It means log K2 minus log K1 will be equal to negative. It means K2 minus K1 will be equal to negative. So it will be possible in just one case when K1 is greater than K2. So K1 is greater than K2. It means when we increase the temperature from T1 to T2, then rate constant of the reaction is decreased because the value of K2 is lesser than the value of K1. So in exothermic reaction, when delta H is negative, we increase the temperature, then the value of Kc will be decreased. Now take the case number 3. So in case number 3, we can understand case number 3. If delta H is equal to positive, if delta H will be positive, then we can say log K2 by K1 will be equal to positive. So it means log K2 minus log K1 will be equal to positive. So it means K2 minus K1 will be equal to positive. So it will be possible in just in one case. The case is if K2 is greater than K1. So K2 is greater than K1. So it means if we increase the temperature from T1 to T2 in endothermic reaction, then the rate constant also increase. So that's why we can say in endothermic reactions, if we increase the temperature, then the Kc will also increase for endothermic reactions. Endothermic reactions. But for exothermic reactions, if we increase the temperature, then the value of the value of equilibrium constant will decrease. Thank you.